Hi folks, so in this video what we're going to do is complete a question here based on the topic of developments, and this question itself comes from the Discover Graphics textbook under Developments 1 chapter. So you can see here it says shown opposite are the dimensions of a cup holder. You can see the little pictorial here and the dimension drawing here. Draw the elevation and plan view of the object in the directions of the arrow shown. So elevation in the direction of arrow A, plan projected underneath it. And then part B, draw the surface development of the tube when flattened out. Okay, so what we're going to do is we're going to do the elevation and plan view first. So in the direction of the elevation, we're going to see kind of this curved surface here at the front, which will appear as a rectangle. And then there's the handle part that obviously is a little bit above it. And in the plan view, we'll actually probably see just a semicircle. Okay, so usually what I do, I try and stick with the normal rules of orthographic projection here. And what I'm going to do is, because arrow A is roughly pointing to right, I'm going to position my elevation on the right hand side of my page. So a little XY line there. Okay, there's my XY line. And now what I'm going to do is I'm going to look at the dimensions of the drawing. So overall it has a height of 95 and an overall length of 60. So starting there on the drawing, I'm going to measure a distance of 60 millimeters. So 0 as far as 6. Actually, I'll keep it a little bit more centered there so it just looks a little bit neater on the page. 0 as far as 6. And I'm going to construct a box going up. And then we have 95. So from 10 up to 19.5, that's our 95. Okay, so everything's going to fit inside of that little rectangle there. And now I'm going to start putting in the details. So looking straight at it, it goes up, or sorry, from the top, it actually comes down 15, down 10, and overall it's 45 down as well. Okay, so from the very tip top, I'm going to measure down a distance of 15, and I'm going to add on another 10, and I'm also going to mark the 45, because that is the height of the curved section. So there we go. I'm going to put in these lines going across. Okay, and then at the very, very tip top, I'm going to measure in a distance of 15 millimeters and 15 millimeters. Now, those 15s came from these dimensions here, in 15, up 15, in 15, down 15. Now, simply to draw that in, I'm going to bring this down, and these guys should meet at an angle of 45 degrees because it was in 15, down 15, so it's actually working out to be a perfect square. And there we go. I'm going to heavy in that structure now. Zoom in there so it appears a little bit bigger on our page. So there is the curved surface at the front, is this line here. That is the bit that's curved at the very, very front of it. We just focus on this little section here. That's the curved section, because you can see it was down 45 from the top. So it's 50 high here. And now we're going to put in the handle. So to get the handle in, 45 degrees, 45 degrees, and put in the little section at the top. And now I'm going to put in the guy there, and this. Okay, and there we go. There is the elevation completed. Now, when we look down on top of it in the plan view, looking from the direction of arrow B, even though this surface is there at the back, I'll still see it just as a line. All I'm going to see then is this little semicircle out at the front. Because it's 60 in length, the semicircle has a radius of 30, but it steps out an additional 10 before we put that in. So, to get the plan view drawn, lengths are brought down. I'm going to keep the distance here to my plan, can be any distance, usually from 10 to 20, so I'm just going to guess it this time. So there's my line at the back. Just going to heavy in that. And now I'm going to measure the distance. Remember that little 10 millimeters down? So from the 4, I'm going to mark as far as the 3. That's my 10mm gap. Do a horizontal line across. And half of 60 then, because that distance there is 60mm, half of 60 is the 30. So I've now found my center point in there. Okay, that little 10, that was the little gap there. So, with that done now, we're going to switch over to a compass, and we're going to put in the semicircle. So, just get my compass ready here. Switch over to the semicircle. So, with the compass, I'm going to do a semicircle with the center point from there, and I'd always just check it before I draw. Just want to check that I have my measurements accurate. Yeah, I'm happy with that. There we go. And now heavy in this little section here. Okay, so that's what the plan view looks like when we look down on top of it. Now what we have to do, that's the elevation and plan drawn. We have to now complete the surface development of the object. Now this object kind of has, I'm going to say, 3 surfaces. Okay, it has the curved surface at the front, it has the back section, and it obviously has a base section as well, because when the cans are put in, you don't want them to fall out the bottom. So what I'm going to focus on first is by doing the back. Now the back has the exact same shape as this guy here. So it's really easy. I can just transfer those measurements all the way across. Okay, by bringing those across, and then I'm going to take, I'll start it here. Okay, now all I'm going to do from here is I'm going to take the true lengths from the object. The back surface was 60 wide, so I could take, you could either measure with your set square, or you could take the distance here, take the 60 from there, and I'm going to mark it out here. So there's the 60. Okay, with that done, I start drawing in this guy. Now, from the top corner here, it was over 15, up 15, works out at a 45-degree angle there, and a 45-degree angle here. And then I have to put in the section for the little handle as well. So I'll bring over this line as well. And then I'm going to take my measurements in again. Actually, I don't need to take the measurements in, apologies. Top here, straight down, and straight down. Now, that there is the back surface. Okay, so I'm going to start to heavy that in. And attached onto the back will be the bottom. So this is going to be a dotted line, because you've got the bit inside that's going to be attached on, if you imagine it folding down. Attached onto the side here, now draw it like about that much down first. 45-degree line, 45 degrees. And we'll just put in the handle now, just the details. Okay, now the reason I didn't heavy this down the whole way is because what I'm doing is, onto this edge here on the left hand side, I'm imagining this whole surface here as if imagine it just folded out, and it's going to go all the way along there like that, and we're going to be folding it out here. That's what's going to happen. So that height will come from here. Okay, so that's going to all fold out there, and then the bottom is going to fold down here. Now remember, the bottom initially it comes out 10 millimeters first, so I'm going to come out 10. Okay, I'm going to measure down to 10. You don't have to take the distances, because I know the measurement. I'll measure the 10, and then with this line being 60, once again I'm going to draw in. I'm going to draw in center point, or mark in the center point, I should say, sorry. So I've now got the center, and what I want to do now, draw in this guy. There we go. Try and keep it as neat and tidy as I possibly can. So there's that little section there. So I've now got two surfaces done. That's the fold line of where the bottom, the base, meets the back surface. And now we have to attach on the side surface. So now that came down to there, and this would attach on. Now this is the challenging part in this question. What's going to be the distance this comes out? What we have to determine first of all is there's a flat section here, which is before it starts the curve. So it's going to come out, it's going to go a distance of 10 millimeters, and then it's going to curve all the way around and another 10. Okay, so we're going to measure 10 millimeters, because that's that the flat bit first of all. So there's the 10. So that's that first little section. So there, that's that first little section. And now we're focused on the curve. Now, the only way to develop out a cylindrical surface is by breaking up that into multiple pieces. So we're going to go 30 degrees from the center of the plan. You have to find the view where you're going to see it as a perfect circle, or in this case, semicircle. So in the plan view, we're going to project all our lines, we're going to split it up into 30, 60 degrees. Now, we've already done the straight bit as it comes out. Now we're going to focus on the curve section. Now, if I was to number the curve section, and I was to say, let's say the straight bit was 0, then it went to 1, 2, 3, 4, 5, 6, 7 to 8. So there's 8 numbers there, okay, starting at 0, and then we've already found 1. Now we have to get the distance from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and so on. So the only way to do that, you can't measure technically a curved line, but what we can do is we can take the closest accurate distance from 1 to 2. Okay, because we split it up into 30-degree segments, okay, or sectors, sorry, what we're going to do is we're going to take the distance from 1 to 2 on our compass like that, which would be the same as the distance from 2 to 3, 3 to 4, and so on until we get to 7. So now that I have the distance from 1 to 2, I can step that off for 6 sections. So I put my compass on 1, I would mark it, there's 2, 3, 4, 5, 6, and I have to go one more, 7, because that's where the curved surface stops. Okay, if I was to number those, there's number 2, number 3, 4, 5, 6, and 7. I just need to extend out my line a little bit further. Okay, and after 7, we have an extra 10 millimeters to get to 8. So after the 7, I'm going to add on 10 more millimeters. And that there is the 8. Okay, so now what I'm going to do is do a vertical line at the 8, and that is the folded surface, or the developed out, I should say, cylindrical surface. Heavy this the whole way along, and heavy this the whole way along. And there we have it. That there is our development. Now you might ask, do I need to put in dotted lines in all this section, fold lines? Not necessarily, because technically a fold line really only occurs where you have a surface meeting, like if you had a specific fold on the page. Like that surface there had to be a fold line, because that is a perfect bend where it bends around. Whereas because this is only curved around, there's technically no fold lines. Okay, so we've got a fold line here and a fold line here. If you were to put them in a test and do fold lines from 7, 6, 5, 4, 3, 2, and even the 1, more than likely you wouldn't be deducted the marks. But technically, by putting in these two, that's all you need. Okay, so there you have it, guys. That there was a surface development question based on the cup holder from the Discover Graphics textbook. Hope you found that helpful. All right.